We are going to move into 9.5, which is the quadratic formula. One thing I need to remind you is, since this is new information, that you do need to be taking notes and watching this video completely. If I ever go too quickly, then make sure you pause or make sure you rewind or rewatch, whatever. Put the closed captions on if at any point you're unsure what I'm saying. I would recommend, if you have a notebook, that you can put all your notes in, or if you don't have a notebook, then you can just paper and find a folder or put it in your binder if you happen to take your binder home. But trying to keep yourself organized as we're continuing on with this. So the quadratic formula is going to continue allowing you to solve quadratic equations. So you've learned two methods so far. In 9.2, you solved using just inverses. So if you had something like 2x squared plus 4 equals 7, you could subtract your 4. Then you could divide by 2. And then this opposite of squaring is square rooting. So you could square root both sides. You should remember that you should get 2 answers, because when you square root, you get one positive and one negative. Then in 9.4, you learned about solving using factoring, because sometimes you can't do inverses. For example, if you have x squared plus 6x plus 5 equals 0, you can't solve this using inverses because you have an x squared and an x, and there's not anything you can do with that to help you. You can subtract this 5, but these aren't like terms that you can combine. You can't do anything with the x and the x squared. So instead, you could factor, and when you factored, you got something that looked like this, where you had your 2 sets of parentheses again, equaling 0, and then you set this one equal to 0, and you set the other one equal to 0, and then you could pretty easily solve those for x. You still would get 2 answers. The final method that you're going to learn is the quadratic formula. And the quadratic formula is useful when you can't do either of these two things. You can't do inverses and you can't factor. There are trinomials that are not factorable, okay? So that no matter what you try and do, you can't get an answer that looks like this. You can't get 2 sets of parentheses. So that's where the quadratic formula is useful. So some of you at some point maybe have heard the song that people played during class time for the quadratic formula. Today's the day you get to listen to that song until you have it memorized. The quadratic formula is something that you will continue to use in future math classes. It will be very useful when you get to Algebra 2 if you already have this memorized, okay? So first, I just want to introduce the quadratic formula, and then we'll talk about some basic stuff with it, and then later on we'll do some examples. So the quadratic formula helps you solve for x, or whatever your variable is, helps you find your solutions for whatever your quadratic equation is. It'll give you your solutions, which remember are the same thing as your roots, your zeros, or your x-intercepts. They all mean the same thing. So whether a question asks you to find the solution or find the zeros or whatever, is asking you the same thing. Solve for x, or whatever your variable is. So the quadratic formula, this is what you will end up memorizing, is x equals, or whatever your variable is, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative b plus or minus the square root of b squared minus 4 times a times c. The whole thing is divided by 2 times a. Notice that b squared minus 4 times a times c, that's the part that's under the square root. So this 2a is not under the square root, it's under the fraction bar. The whole thing is being divided by 2a. So this is what you will need to be memorizing, and we'll be able to use. We'll go through several examples together so that you can see how to use it. A, B, and C are numbers from your equation, which we've talked about before. Remember that A is your number in front of x squared, which in this case would be 1. B is your number in front of x, in this case would be 6, and C is your constant, which in this case would be 5. So those are the numbers that you would fill in, and then you would start simplifying. And we will go through the simplifying together, at least for the first couple. One thing that is very, very important as you start, which is the same thing that was very important when you did solving by factoring, is you first have to get your equations in standard form. Ax squared plus bx plus c equals 0. So that you have your x squared term first, your x term next, your constant last, and then it has to be set equal to 0. So that's the first thing I want us to try and practice a little bit of, is getting it into standard form. Okay, so we'll start with some easy ones and then we'll move on to a couple of harder ones. Let's say I have 3x squared plus 4 minus 5x equals 0. So standard form, there are two important things. Number one is you have to be set equal to 0, which we have, so that part is good. The next thing that is important is the order of your terms. You have to have x squared, then x, and then your constant. So if we look at ours, I have x squared, but then it's not the x term and it's not the constant. So in this case, all you need to do is rearrange. These two are in the wrong order, so I need to take this term and flip them so that I have 3x squared minus 5x plus 4 equals 0. The sign came with the term. It's negative 5x or minus 5x, so it's still minus 5x, and it's positive 4, so plus 4 here. That is now in standard form. And you should be able to identify for me that A is 3, B is negative 5, and C is 4. Another example, let's do a little bit harder one. Let's say we have 5x squared minus 2 equals 7x. So two important things is you have to be set equal to 0, and you have to be in the x squared, then constant order. So neither of those two things are happening right now. I don't have equals 0, and I'm not in the right order just yet. So we should work on right here. I have this 7x that needs to move to the other side, which we've talked a lot about how to move it to the other side. It is a positive 7x, so you should move it by subtracting 7x. And we're going to move it to the other side. If there was a like term, you would combine it with its like term. But in this case, there's not, because x squared and x are not like terms. So instead, you kind of want to just place it where it should go. So remember, it should be x squared and then x and then constant. So I'm going to squeeze it in the middle here, in between the x squared and the constant. So then when I write my answer, I get 5x squared minus 7x minus 2 equals 0, where A is 5, B is negative 7, and C is negative 2. Three p plus 2 plus 4p equals 7p squared minus 8p. Okay, a little bit more stuff going on here. So as you get started, there's a couple of things and a couple of methods of how you can start, kind of a personal choice. Some of you may try and move these terms first because you know you want to be equal 0. Some of you may notice that you have like terms right here. Remember, like terms have to be on the same side of the equal sign. So 3p and 4p could right away be combined. Okay, either method would work. Let's go about combining like terms first. So I have 3p plus 4p. Those are like terms that need to get combined. 3p plus 4p is 7p. And then everything else just needs to come down because I didn't change anything to it. Now you can work on moving both of these terms, and you can do them in the same step. So I have a positive 7x squared, so I need to subtract, p squared. So I need to subtract because it's positive. And when I move it over here, first I look for like terms. I have p squared, but none of these over here are p squared. So I don't combine it with anything. So instead I'm going to look to see where should it go. P squared, should it be in the front, squeeze in the middle, or go at the end? P squared should go in the front. So I'm going to put minus p squared here in the front. At the same time, you also can move your minus 8p. So since it's minus, you need to add 8p. You would look over on the other side for like terms, and it is a like term with 7p. So I add 8p to that term. So this would give me negative 7p squared. I'm going to combine my like terms. 7p plus 8p is 15p. The 2 is just going to come down. These are gone and these are gone, equals 0. And then you should be able to identify for me that A is negative 7, B is 15, and C is 2. Let's do one more together. Okay, this is a little bit more complicated. You probably won't have ones this complicated, but I want to show you this example. So in this one, because you have these parentheses, you should start with your distributing. And remember, there's a 1 here and a 1 here. So when you distribute 3t to the first times 2t to the first, 3 times 2 is 6. T to the first and t to the first gives you t squared. And then 3t times negative 4 is negative 12t. Then you just bring down your plus 5t equals 7 minus 4t squared. Now if I look, my next step might be to look for like terms, which I do have some. Remember, like terms have to be on the same side. You have negative 12t plus 5t, so 6t squared. And then combine your like terms. Negative 12t plus 5t is minus 7t equals 7 minus 4t squared. No other like terms, so now I can start by moving my other terms. I have this 7 that needs to move, so minus 7 since it's positive. Since it's your constant, think about should it go in the front, squeeze in the middle, or go to the end. Constant goes at the end. You also can get rid of your minus 4t squared. Since it's minus, you're going to add. Looking on the other side, I do have a like term with it. That 6t squared is this like term. So now work on combining. You have 10t squared minus 7t minus 7, gone and gone, equals 0. Hopefully you can tell me that A is 10, B is negative 7, and C is negative 7.